Good morning, guys. In this video, we'll be solving an additional problem on Chapter 6 Structural Analysis where I have a beam with 4 unknowns and the question is to find the reactions at its supports. So guys, as you can see here, we have a fixed support at A. What does this mean? Remember, in the fixed support, I have 3 reactions, 2 forces reactions and 1 moment reaction. So basically at A I have 3 reactions and I have also a roller at C, which means I have an additional reaction which is basically here vertical, so that I have 4 unknowns. And I know that in 2D the number of equilibrium equations is only 3. Sum of fx is equal to 0, sum of fy is equal to 0, and sum of moment is equal to 0. So what should I do in order to find the reactions at A that are 3, are AY, AX, and MA, and the roller reaction at C, which is only one force, one vertical force CY. So what should I do? Basically, guys, I have a pin here. And I know, guys, that if I have a frame like this case, so why is it a frame? Because in fact, I have a force at AB and a distributed load at BC, which means I have forces on the members, and this means that this is a frame. Remember, in the truss, I only have that the forces are only exerted on the joints. So guys, if I have a pin joining 2 members, I can disassemble these 2 members and put the reactions at this pin, and these reactions could be horizontal and vertical like this case. So I can basically separate these 2 members. Why? Because in fact, if I separate these 2 members, I will have 3 unknowns at A, 1 unknown at C, so 4, and 2 unknowns at B, which is 6. And then, guys, I can apply for each member 3 equations of equilibrium. And since I have 2 members here, so this means that I will have 6 equations, 6 unknowns. So this means that I can find my unknowns. So let's do it. Okay, so guys, this is my beam. I have 3 unknowns at A, 1 unknown at C, and since I have 4 unknowns, I should separate my members at the pin, which is here at B. And don't forget, guys, that at B I will have 2 components of forces or 2 forces, because in fact AB and BC are not 2 force members. I have forces on them, so this means that at B I will have 2 forces. Okay, so guys, let's now assume the direction of reactions at A, B, and C, and then start to solve. Okay, so I will assume that this is AX, this is AY, and this is the moment. Don't forget the moment at A, because in fact this is a fixed support, as you can see here. I will assume that this is BX, and this is BY. And since, guys, this is Bx and By on the member AB, then at B on the member BC, I will have opposite forces. Okay, so let's say this is Bx and this is By. So that, guys, if I rejoin AB and BC, these internal forces will vanish, and I will assume that at C I have a vertical reaction Cy. Okay, so guys, how to start? What do you think? Should I start by the member AB or by the member BC? In fact, guys, I should choose the member that has the least number of unknowns, which is here BC, because I only have 1, 2, 3 unknowns. While in the member AB, I have 3 reactions at A and 2 reactions at B, so 5 unknowns. Of course, guys, I will start by member BC, and then I can apply the sum of forces, sum of X, Y, and sum of moments equal to 0. Guys, I will start basically by by sum of fx. Why? Because in fact I don't have any fx on the member BC, so of course bx should be equal to 0. So basically, guys, from the sum of fx is equal to 0, this will give me that bx will be equal to 0, and here guys I get rid from the first unknown, which is bx. Now I know that the question is not to find bx and by. However guys, if I know bx and by, I can find all my other unknowns. Alright, now guys I can find cy, because in fact if I do the sum of moments around B to get rid from all the reactions at B is equal to 0, this will give me what? If I do the sum of moments around B is equal to 0, this will give me that Cy times 2 minus, this is a regular distributed load, so I can find directly the area 4 times 2, and this resultant force will be at the middle point of this 2, so times 1 is equal to 0, and from here, from this equation, I can find Cy, which is basically equal to 4, and it is positive, which means that its direction is correct. So Cy is equal to 4. Once I know Cy, guys, I can find By from the sum of Fy is equal to 0. So since I know guys Cy, and I know that the regular shape is equal to 8 located at the middle point of BC, so I can find guys By. Basically, By plus Cy minus this distributed load that is equal to 8 is equal to 0, which means guys that By plus Cy is equal to 8, and this means that By is also positive, and it is equal to 8 minus 4, that is also equal to 4. Okay, now guys, I know Bx and I know By. So Bx is equal to 0 kilonewton, By is equal to 4 kilonewton. So I can now go to the member AB, and fortunately I only have 3 unknowns in the member AB that are the reactions at A, and I can find them. So basically guys, I can start by also the sum of fx is equal to 0. Why? Because in fact bx is equal to 0. So I only have ax and the projection of 10 kilonewton on x, which is negative here, and it is equal to minus 10 times 3 over 5 is equal to 0, which means guys that ax is equal to 30 over 5, which is 6 kilonewton. So guys, Ax is positive and it is equal to 6 kilonewton. Now guys, I can find also Ay, because I know By and I know the projection of 10 kilonewton in the y direction, so I also can do sum of Fy is equal to 0. And this means guys that Ay plus by. Okay, so guys, here I did a mistake. Basically, this by is downward because I take this by as in the upward direction. So let's correct this. So guys, pay attention. Bx, By in the member AB should be opposite than Bx, By in the member BC, and sum of Fy is equal to 0 will give me that Ay minus By now, minus 10 times 3 over 5 is equal to 0, which means guys that Ay is equal to By, which is 4 plus 6, so it is equal to 12 kilonewton, and it is in the correct direction. So what is remaining in the reactions is MA. Now how to find MA? You can take any point on the member AB, because in fact even if you take the sum of moment around A, MA will remain in the equation, so it will not vanish. This is a moment, so I can take the sum of moment around A is equal to 0. Okay, and this means guys that MA, so I'm taking the positive direction as clockwise, plus Of course, guys, the projection of 10 kilonewton in X will give me a zero moment because it is basically passing through A. So I will only have the projection of 10 kilonewton on Y, and this is basically doing the same positive direction. So plus the projection of 10 kilonewton on Y, which is basically 4 over 5, 9 times 4 over 5 times the distance between them, which is 2. And then, guys, um, plus also bx times 4 equal to 0, which means that MA is negative, and I think it is equal to 32 Newton. And this is the end of this problem. Thank you.